Okay, lesson 8.4. Find the area of triangles. So, 8.3 was all about the rectangles and squares, and so we're going to continue on with triangles. Now, we know that the relationship between a rectangle and a triangle is that a triangle is always going to be half the area. Half the area. One triangle will be half of the area of a rectangle. Okay? If that triangle is half of that rectangle. So here, that's where that formula comes from. So if you can't remember the formula, this is where it comes from. The diagonal drawn in this rectangle forms a triangle, and it ends up being half of the area of the rectangle. So the area formula for a triangle is 1/2 base times height. The new thing is 8.3, areas of similar polygons. Now, we've talked about similarity, and we know that two figures can be similar if all the angles are the same and the sides are proportional. So if two polygons are similar with a scale factor of A over B, then the ratio of the areas will be the square of that, A squared over B squared. And so you can simply skip to that to get the ratio of their areas. So the first example, find the area of the right triangle, says use the formula for the area of the triangle. Well, we can label this as the base and this as the height. Now the key thing with triangles is making sure that your height always forms a right angle with that base. If you cannot find the right angle, then that is not your height. The height must also always form a right angle with that base. Think about when you get your height at your doctor's appointment, or anytime you try to calculate your height. You're not going to stand in a slanted direction. You're going to stand straight up and form a right angle with the floor. So that's what you want to look for when you're looking for the height of a triangle or the height of any figure in general. So in this case, we're going to do 1/2 the base times the height. So that's going to be 1/2, 15 times 8, which will give me 60. When I substitute all my numbers in, and what units are we talking about? We're talking about yards, and we're talking about area, so it's going to be square yards here. So take a moment to complete 1 through 3. Calculate the area of these triangles. So the formula area equals 1/2 base times height. So we will say 1/2 the base of 12 times the height of 5. You can also write it like this. You can also say 12 times 5 divided by 2. Either way will get you the same answer. That is 1/2 12 times 5. So 1/2 of 12 is 6. 6 times 5 will get me an area of 30 square inches in this case. Number 2, we do 1/2 base times height. And our base, we could say, is 18, and the height is 8. And so when we take 1/2 of 18, that is 9. 9 times 8 will give me 72, and the units would be square centimeters. And lastly, number 3. Area is base times height divided by 2, or 1/2 base times height. I'll use the other formula so you can see how it looks. Base times height, 4 times 7, but then we have to divide it by 2. So 4 times 7 will give me 28. 28 divided by 2 will give me 14 square feet. The next example 2 says find the area of the triangle here. Now, if I give you a triangle like this, again you want to identify your base and your height. What if I was to give you other side lengths? What if I was to say, well, this is 12 centimeters and this is maybe 6 centimeters. And we're trying to find the area of this triangle. Um, you should know automatically that the height must form a right angle with that base. So this would be my base, this would be the height, and I would want to mark out the extra information that we don't need to calculate the area of the triangle. So I just want you to know that for future reference. So we're just going to plug in our numbers into the formula. 1/2 times the base times the height. 1/2 of 8 is 4. 4 times 4 is 16. So we substituted our numbers into the formula. So we get an area of 16 square centimeters for this triangle. So for 4, 5, and 6, it's going to be the same case again. You'll multiply your base times height and divide by 2. And I'll give you a moment to do that. So on number 4, the area would be 20 times 13 divided by 2, which should give me 130 square centimeters. Number 5, area, base times height divided by 2, 9 times 6 divided by 2. And so we get an area of 27 square inches for number 5. Number 6, the same setup. 14 times 5 divided by 2. And when we simplify this, we get 35 square feet. Alright, example 3, find the base. Now this time, we're given the height and we're given the area of this triangle. So the area is 42 square feet. And we're given the height. We need to find the base. We don't know the base of this triangle. So that's our missing length there. And so we're going to have to work backwards. Anytime we're missing the base or the height, we're going to have to, work backwards and solve for that missing value. So we're going to plug in everything we know. The area is 42. We know that the height is 6, so we're doing 1/2 the base times 6. And the next step we would want to do is to multiply by both sides by 2 to get rid of this 1/2. And so we get 84 equals base times 6, and then we'll divide each side by 6. Okay, so when we do that, we're left with 14 feet as the base. So when you get 14, you should say, well, is 14 times 6 divided by 2, is that 42? And if it is, then you've done the correct work. Alright, so take this time to do number 7, 8, and 9, calculating the missing height, base, or in each problem. So on number 7, we would say, well, the area is base times height divided by 2. The area is 15. My base is 10 inches, and my height is missing. And I just divide that by 2. So if I'm dividing by 2 and I want to get rid of this fraction, I will do that by multiplying by 2 on each side of the equation. So I get 30 equals 10 times h. And to solve for h, we would divide by 10 on each side. And so we get a value of 3, and we're talking about inches here, so 3 inches. Don't forget your units. For number 8, we know the area is 126. The base we do not know. The height is 12 divided by 2 is the formula for a triangle. We then multiply by 2 to get the 2 out of the denominator. These cancel. 2 times 126, well, that will give me 252. equals 12 times B. And when I divide by 12 on each side, I get B equals 21 centimeters. Number 9, the area is 6 square feet and the base is 6. The height we do not know this time. Divide that by 2. Solving for h, we would multiply each side by 2. These cancel. Get 12 equals 6 times height. Divide by 6. So 2 equals h. And don't forget the units. That would be 2 feet. Okay, now for the newer stuff. Example 4 says triangle ABC is similar. Don't forget this symbol means to be similar to one another. Find the scale factor of triangle DEF. So this is the bigger one to smaller triangle. So find the scale factor of the bigger to the smaller, then find the ratio of their areas. So first, we could pick any two sides, we'll pick one of the bigger first. So we could say, well, 10 over the smaller, that corresponds with 10, that would be 5. 10 divided by 5 would be 2 over 1. If you picked 4, like this example did, you would need to find the height that corresponds with 4 in the other one. That would be 2. 4 divided by 2 equals 2 over 1. So this is my scale factor. And by the theorem that we learned about at the beginning, the ratio of the areas would be the square of those values. 2 squared over 1 squared, which would be 4 over 1. And so you could actually calculate the area of each one of those to see if that truly is the ratio of their areas. So if we look at triangle ABC, and just calculate the area real quick, it'd be 1/2 the base times the height. When we do that, we get just 5 as the area, 5 square units. For triangle DEF, 1/2 the base times the height. Well, when we do that, we get 5 times 4, which is 20 square units. And if we do the bigger to the smaller, it'd be 20 divided by 5, which would equal 4 over 1, which matches up with that. So if you can remember theorem 8.3, this will save you time. You don't have to calculate the area of both triangles. You can go straight to getting the ratio of their areas. So take this time to do number 10, the exercise for example 4. Alright, so the scale factor of the smaller to the bigger this time. So I could pick the height of the smaller, 3, over the height of the bigger, 5. And that would be my scale factor. Then, to get the ratio of the areas, we would just square that. 3 squared over 5 squared. So 3 squared is 9, and 5 squared is 25. So that is the ratio of their areas.